Hey guys, welcome back to Geometry with Zach, and today we're going to be going over the simplest radical form. So this is actually an extension from my last video, which was on the distance formula, because when you get your answer from that, it might not be your final answer. So let me just read through this, and then you should be able to see what I'm talking about. So after using certain formulas or equations, you may end up with a radical number. The radical symbol is this. So you'll have your number here, and then that's a radical number. However, this is not your final answer because we still have to put it into simplest radical form. This is going to change a big radical number like rad 64 into a smaller number like 8. However, they're still going to have the same value. So if you put rad 64 into Desmos, it's going to give you back equals 8. So rad 64 is not the same as regular 64. Just remember that because it has that radical symbol. All right. This is because 64 is a perfect square. That's why it's giving you 8. You'll know if a number is a perfect square when a number can be multiplied by the same number to get it. So that sounds a little weird, I know, but it's literally just if you're multiplying 8 by another 8, then you're going to get a perfect square number because you multiplied 8 by itself. Same thing can be done with 3. So if you have 3 times 3, you get 9. That's like literally the same thing. 9 is your perfect square number there, and you're multiplying 3 by itself. All right. Here's a visual for some perfect squares just to show you. This is for a little later, so I'll get rid of that. But yeah, so the numbers in red are your perfect squares. So you can see 1 times 1 gives you 1, 2 times 2 gives you 4, and that just keeps going on. So if we follow this logic, radical 36 is going to simplify down to regular 6 because 36 is a perfect square. Yeah. But what if your radical is not a perfect square? Well, we could still get it into simplest radical form. It just takes a little more work. We can simplify it twice, and we can still get there. Let's do that with radical 12. So the first step here is to find the largest perfect square you can find that goes into 12. So let's use the chart. We're going to look at 12, right? And just think to yourself, like, look at the perfect squares. Think of 12. What's the largest one that can go into 12 and divide nicely? So that's going to be 4. So we can take 12 and divide it by 4, and then you get 3. And you see how it works out nicely. There's no decimals here or whatever. So that means that's the radical that you should be using. Just make sure it's the largest one if you're doing this with a bigger number. Yeah, so the first step is to find that largest perfect square, and then we can divide it to find the other multiple for 12. Then we can rewrite the rad 12 as rad 4, rad 3. So you're literally just listing out the two multiples of 12 that you used to get your answer. So it's rad 4 times rad 3. This is, just imagine there's a multiplication symbol there. I know it doesn't show when you write it out, but that's what you really should be imagining in your head. Because eventually we're going to simplify this part down more, and you're just going to keep imagining there's this multiplication here. Yeah, so rad 12 is literally equal to this new way you're writing it out. You're not changing the value of anything. It's just to rewrite it in a more simple way, which is how they want it on your exams, on your state exams, like the Regents, stuff like that. All right, let's go back in, and we're going to simplify the 4 now. So if we look at the chart again, you're going to notice that 4 is a perfect square, right? Yeah, so we can simplify the rad 4 into regular 2 because 2 times 2 is 4. So rad 4 is a perfect square, and 2 is what it becomes, right? It's the same value. And since 3 is not a perfect square, we're going to leave that alone as rad 3 because that's already as simple as it can get. It's not like it can simplify down like rad 4 can into 2. It stays the exact same. So now we actually have our final answer now. It's not that long of a process. You just kind of have to know the steps to go through. Yeah, so we can rewrite rad 4, rad 3 as 2 rad 3 because the rad 4 is equal to 2. This is the same as writing rad 4, rad 3, and it's actually the same as writing rad 12. It's just this becomes this, and this becomes this. It's the same, like, value and everything. It's just a more simple way of doing it, and that's how they want it. Keep in mind, your final answer doesn't always look like this. If it's a perfect square, it's going to look like this. It's not going to have a radical. Or if, like our rad 3 can't be simplified anymore, you're going to have 2 radicals in your answer. And that's perfectly all right. Don't question it. Just keep thinking, can this be simplified again? And if it can't, then you're done. So that's awesome. For some more examples, take a look back at the chart. I would personally recommend you to try out rad 24, rad 50, and rad 36 because it's some pretty easy practice and it divides nicely like we did with rad 12. Some of your bigger numbers, it might be a little harder to divide because you're going to be wondering, like, what's the absolute biggest perfect square I can use? But when you're just trying to, like, get used to it, I think that these are some good ones to start with. So try those out, and if you have any questions, please leave me a comment. I'll respond to you as soon as I can, and I'll really try to get you to understand it and help you out. All right, thanks so much, guys. Peace out.